about chemical nomenclature. So remember, nomenclature is a naming system. In order to effectively do this, we're going to go through some terms that you should already know to help make sure that you're going to understand what you're doing. So your goal is, by the end, you should be able to apply this information, use some formulas in order to name them chemically. An ion is a charged particle. A cation is a positively charged particle. It will lose an electron. This is a metal. An anion is a negatively charged particle. It will gain an electron. It is a nonmetal. Note that your metals are in blue and your nonmetals are in red. A compound. So we've talked about compounds before. There are two or more different atoms bonded together. You have more than one type of compound. So an ionic compound is formed between a metal and a nonmetal. Note when you see B/T, that is between. So molecular compound is formed between nonmetals. Note the underline is S. So two or more nonmetals bonded together, you have a molecular compound. So ionic compound, orange, molecular, pink. So binary compounds, two elements bonded together. Tertiary compounds contains at least three elements that are bonded together. So if you see three capital letters, you know that you have a tertiary compound. Transition metals are in green. Remember, transition metals are groups 3 through 12 on the PT, which is the periodic table. So they can form more than one ion. Polyatomic ions, two or more atoms with an overall charge. So remember, you're going to have to start learning those transition metals, groups 3 through 12, as well as the polyatomic ions on your reference chart. Prefixes. So you only use prefixes with molecular compounds. So you need to make sure you learn those prefixes. So 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 is deca. So steps for writing binary ionic compounds. So pretty simple steps. You've used some of these same steps when you're writing the chemical formulas. Step 1, write the metal first. Step 2, write the nonmetal second. Step 3, change the ending of the nonmetal to "ide." So in your example here, you have NaCl. Sodium is in group 1, therefore it has a positive 1 charge. Remember, if you don't see the number there, it's understood to be 1. Chlorine is in group 17, it's a halogen. You use the octet rule, you remove the 1, 7 minus 8 gives you a negative 1 charge, that's why you just see the negative sign here. So you don't need to do crisscross because the positive 1 plus the negative 1 gives you 0. Step 1, you write the name of the metal, sodium, you write the name of the nonmetal, chlorine, you change the ending of the nonmetal to "ide." So this compound is named sodium chloride. Steps for tertiary compounds. So remember, if you see 3 or more capital letters, you have a tertiary compound. They could contain a transition metal, a polyatomic ion, or both. So step 1, write the metal first. Step 2, use the Roman numeral if a metal is a transition metal. Step 3, name the nonmetal. Step 4, change the nonmetal ending to "ide." So in this example here, we have Cr2, which is in green, which is a transition metal, and we have oxygen, which is a nonmetal because it's in red. Remember before when we talked about if the charges were not the same, you use crisscross. So oxygen is in group 16. You remove the 1. 6 minus 8 gives you a negative 2. So the 2 that was here that belongs to the oxygen went to the chromium. Chromium, we know now, has a 1 charge because it is a metal, so it's a positive 1 charge, but the 1 is here with the oxygen. So in order to make this a stable compound, you have to have 2 chromiums for 1 oxygen. So when you write your Roman numerals, you're going to write a 1. So step 1, chromium, 1. Chromium, step 2, 1, and then you have oxygen. So now we need to do step 4, which is which is change the ending. Chromium 1 oxygen becomes chromium 1 oxide. So steps for binary molecular compounds. So now we get to use some of those prefixes. So use the prefix for the number of atoms of the first element. So if it is going to be equal to 1 or the number of atoms equal to 1, that's mono. You're going to omit that. You're not going to write that. So step 2, name the first element. Step 3, use the prefix for the number of atoms of the second element. Step 4, you're going to name the second element. And then 5, change the ending of the second element to "ide." So you're going to know how to write the order of your nonmetals because you're going to use this fact. The further left it is on the periodic table, and the further down it is, that element is going to come first. So if they're in the same family, that means the one further down the column is going to go first. If they're not in the same family, which one is the furthest left is going to be named first. So if you look here in your example, you have CCl4, all in red, all nonmetals. So carbon and chlorine, both nonmetals, but the carbon is listed first in the periodic table. Carbon is in group 14, chlorine is in group 14, group 17. So that's why the carbon comes first. So carbon is named step 2 here. And then chlorine, we need to number prefixes, that's step 3. And then we're going to do step 4, name the element, that's chlorine, carbon tetrachlorine. So step 5, you're going to change the ending to "ide." So then we're going to end up with carbon tetrachloride. So application finally. So now we get to apply this information. So problem 1, calcium, which is group 2 metal. So it has a +2 charge. Then you have iodine, -1 charge, halogen, 7 minus 8 gives you a -1. So switch charges. So we end up with calcium I2, which is going to be calcium iodine. Change the ending to calcium iodide. Problem 2, you have all nonmetals, so you need prefixes here. So you end up with sulfur. Then you have 3 oxygens, so sulfur trioxygen, which is going to become sulfur trioxide. Problem 3, you have magnesium, +2 charge, -1 charge on your nitrite, which is a polyatomic ion. So switch charges. 1 goes from the nitrite to the magnesium, the 2 goes from the magnesium to the nitrite. So that's how you end up with magnesium with the brackets to separate the 2's. Magnesium comes first, your nitrite comes second. So magnesium nitrite. Step 4, or problem 4, you have zinc and you have carbonate, Zinc is a transition metal, so you need to remember it's one of your exceptions. It will only always have a +2 charge. Carbonate has a -2 charge, that's why you don't see any brackets here or any additional subscripts because the charges are already balanced. So therefore this is zinc, Roman numeral 2, carbonate. Problem 5, you have carbon and you have sulfur, all in red. You're going to need some prefixes here. Carbon comes first on the periodic table before sulfur. So listed first we have carbon. This 2 here becomes di, and then we need to put our sulfur here, so carbon disulfur. We need to change the ending, so this becomes carbon disulfide. So you need to work on worksheet number 4, and then you can practice with worksheet number 5. There are also some polyatomic ions and some transition metals you can work with on worksheet number 3. Good luck.